Hi everybody, welcome to this Saturday session with exam revision. So today we're going to look at some Leaving Cert ordinary level content, and what we're going to do is we're going to go through complex numbers and we're going to do kind of one or two of each type of question that can come up. Okay, so by the end of this video we will have the majority of this chapter done. I really like the complex number chapter because it is very isolated, so it tends to come up on its own as a short question. Not much overlap between that and other topics. Okay, obviously we do need a basic understanding of kind of our algebra skills. They will come into this, but in general it tends to be a standalone question on the paper, the entire question on complex numbers. Okay, so what are we going to look at in this video? So we're going to look at plotting them. So plotting them on the Argand diagram, that's usually the part A of our question, and usually mixed in with that then somewhere is adding and subtracting. And then we're going to look at multiplying and dividing complex numbers. We're going to rely on our algebra a little bit for that, but there's a few kind of tricks that are very specific to complex numbers. And then we're going to look at finding the conjugate and finding the modulus. Okay, at the end then we'll go through some exam paper questions, how the questions tend to come up, and we're going to kind of look at the most, I guess, predictable type of questions, the things that have come up year after year, so the skills that you really need going into your exam. So we're going to get straight into it. Just kind of a side note here, we're going to just look at what a complex number is first before we get into this. Okay, so complex numbers, we tend to call them the letter Z. Okay, so anytime you're given a complex number, can be W sometimes too, but they're usually Z is equal to, and then some number, so we're going to say 4 plus something I, so we'll go with 3I. Okay, now that's a random complex number I've just made up out of the top of my head. And what a complex number actually is, it's a number that's made up of a real part and an imaginary. Okay, that's basically for ordinary level, that's really all you need to know. So a complex number, it has a real part and it has an imaginary part to it. Okay, now for plotting them on an Argand diagram, so this is basically just your same type of diagram that you would use for coordinate geometry if you were asked to plot points. Along the x-axis is the real part, and along the y-axis is the imaginary. Okay, and we just plot. So for example, we have Z1 here. Now, the only reason the 1, 2 and 3, just to make them different, call them different names. Okay, so we have Z1 is equal to minus 3 plus I. Now, kind of like algebra, if you can just pop a 1 in there. So minus 3 plus 1I. So we're going to minus 3 on the reals. And then up to 1 will give us that point there and Z1. Okay, then for Z2, it's 4 minus 3I. So have a think, where do you think this number will be plotted? So we're going to go over to 4 and then down to minus 3. So it is going to be here, and we're just going to label that as Z2. And then finally we have 2I. Now that doesn't look like the kind of normal one. So you usually have a number and then plus or minus something I. So I can actually say that that's the same thing as 0 plus 2I. Okay, so 0 on the real axis would be here. And then plus 2I will bring me up as far as here. So that's Z3. Okay, that is nearly always, when we see the exam paper questions, it is nearly always your part A of the question. So that's a really important skill. People sometimes tend to kind of rush through it, but that could be worth as many marks as the hard things that we're going to get to in a couple of minutes. Okay, so definitely worth spending your time on it, making sure you've gotten it right. There's just one other way that can come up. So we could be given this point here, and we're going to call it W, just because that letter is sometimes used in complex numbers. And it could be, right, W in the form A plus BI. Okay, so all that is asking you, it's in very complicated mathematical language. All it's asking you is, what is the point or the complex number W? So W, we can see it's 2 on the real and then 3 on the imaginary. So it'll be W is equal to 2 plus 3I. Okay, so there's only two ways that they can complicate this. They can say, plot the following points, or what is the following point? Okay, quick introduction there about what a complex number is. I would say in general for Leaving Cert Ordinary Level Maths, you don't need a huge understanding of it, just kind of be familiar with what it is. The complex number, it has a real part and an imaginary part. Okay, and you can be asked to plot it or to write down the coordinates. Okay, so we'll move on now. We're going to see that again anyway when we reach the exam questions. So now what we're going to do is we are going to do our adding and subtracting. Now, the good news is if your algebra is okay, you'll be absolutely fine with this. Okay, so I made up two random complex numbers here. So I said 7 minus 3i and 2 plus 5i. And what we're going to do is we're going to add those together. Now, what you can do is you can add the real parts and add the imaginary parts. Okay, but you can't add them together. Okay, so I can say that Z1 plus Z2, I'm going to add the real parts. So it's going to be 7 plus 2, that's going to be 9. And then minus 3 plus 5 will be plus 2i. Okay, so if you can kind of think of the i's as x's, they can't be added to numbers without i's. Okay, then we'll have Z1 minus Z2. So this will be 7 minus 2, so that'll be 5. And then minus 3 minus 5 will be minus 8i. Okay, so that is your adding and subtracting. Again, if your algebra is okay, you'll fly through this. Okay, really all complex numbers is, it's another branch of algebra. Now I'm going to make up a new example down here. Okay, so I'm going to say that Z1 is 4 plus 6i. And I'm going to say that Z2 is 3 minus 2i. Okay, what I want you to do, I want you the same questions again. Z1 plus Z2 and Z1 minus Z2. Now, you will probably come across a little problem and some people might make that mistake. That's perfectly fine, just with your signs when you're subtracting them. So if you want to pause the video, the first one should be fine. The adding, the minusing one might be a little bit difficult. So if you want to pause the video, give them a go. And even if you do make a mistake, at least you'll be able to correct the mistake now and you will know going forward. Okay, so first for Z1 plus Z2, we're going to add the real parts and add the imaginary parts. So we'll have 4 plus 3, that's going to give me 7. And 6 plus minus 2i, that will give me plus 4i. Okay, now this is where I think people are more likely to make the mistake. So it's going to be 4 minus 3, which will give me 1. And then we're going to have 6i minus 2i. Now, we're subtracting and we have a minus sign. So there's two minus signs there coming together. We know two minus signs. So I'll just write down his 6 minus 2. Okay, two minuses actually make a plus. So that's going to change into 6 plus 2i, which is going to be 8i. So your answer will actually be 1 plus 8i. Okay, how did they change to a plus? It's because it was 6 minus 2. So your two minus signs there coming together made it into a plus. Okay, and that is our adding and subtracting. Once we do multiplication now later on, we're going to be doing more adding and you'll get to practice that skill again. But that's kind of the basics of it. Okay, now into multiplying. There's a few there's one rule in particular about this, but again, if your algebra is okay, there's only one rule you need to learn. Okay, so I have two complex numbers there. Z1 is 4 plus 7i, Z2 is 2 plus 3i, and the first question asks me for Z1, Z2. Now, really what this means, this is Z1 multiplied by Z2. Okay, I'm going to set this up in brackets, so it's going to be 4 plus 7i and 2 plus 3i. Okay, when we see things squished together like this, it means multiply. Now, I don't know what way you were taught to multiply out brackets in algebra. You can do whatever way works, provided you get the same answer as me. Then you'll know you're correct. But what I always tell people to do, write down the second bracket twice and split up the first bracket. Okay, so that trick works for algebra or for complex numbers. Now all we have to do is multiply in. So 4 by 2 is going to give me 8. 4 multiplied by 3i will give me 12i. 7i multiplied by 2i is going to give me 14i. And 7i multiplied by 3i is going to give me plus 21i squared. Okay, so exactly the same if this was normal algebra with x's and y's or a's and b's, whatever letter they choose. But this time there just happens to be i's. Now I'm going to tidy that up a little bit. So it's going to be 8 plus 26i plus 21i squared. Now, there is a really important rule. Sometimes a lot of the time it is told to you in the question, but you need to know, and I would learn that by heart, I squared is equal to minus 1. Okay, so whenever you end up with an I squared in your question, you're going to replace it with a minus 1 in a bracket. Okay, the most important rule in complex numbers. Okay, so I squared is equal to minus 1. So this is going to stay the same. And then just replace the I squared with minus 1. We can now simplify this even further. So 8 plus 26i, 21 multiplied by minus 21, or 21 multiplied by minus 1 will equal minus 21. So now we can do 8 minus 21, which is minus 4 plus 26i. Okay, so that rule about minus 1 or replacing I squared with minus 1 is super important. We're going to see that a lot. Okay, also being able to multiply out those brackets is really important as well, because it comes up later on when we get to the hard parts, when we get to division. Okay, that's part 1 of that question done. Again, I'm going to give you another example after this that will help you practice it. But we'll see more multiplication now in the next 2 parts. So for part II, it says Z1 to be squared. Now, if I tell you 4 squared, okay, that's equal to 4 multiplied by 4. Okay, so Z1 squared, and that was just a random example, but Z1 squared is going to equal Z1 multiplied by Z1. Okay, so anything squared is just multiplied by itself. So it's going to be 4 plus 7i. 4 plus 7i. Okay, now again, multiplying out 2 brackets. If you do it this way, kind of with the arrows, that's fine. Or if you write down the second bracket twice, split up the first bracket, whichever works, as long as you're going to get the same answer as I do here. Okay, so write down the second bracket twice, split up the first bracket, and now off we go with our multiplying. So 4 by 4, 16. 4 by 7 is 28i. 7 by 4 is 28i again. And then 7i by 7i is plus 49i squared. Okay, now tidy this up further. It'll be 16 plus 56i plus 49 by minus 1. 16 plus 56i minus 49, because we multiply minus 1 by 49, and we can do 16 minus 49 to give me minus 33. So my answer is going to be minus 33 plus 56i. Okay, just a note, we usually put the real number first and then the imaginary number, so that's in the correct order there. Okay, so the last part now looks a little bit more intimidating. Okay, we're going to do 3i multiplied by z1 plus 5 times z1. Okay, what I'm actually going to do is I'm going to do these in separate parts and then add my answers together. So first I'm just going to find 3i z1. So all that means is 3i multiplied by z1, which is going to equal 12i plus 21i squared. What do we know about I squared? We change it to minus 1. So that's going to be minus 21 plus 12i. Okay, so all I did here, I just took the first part because there's a lot of kind of work to be done before we can add them together. Okay, so this is going to be important for later, so I'm just going to put a little box around it. We also need to find out 5 times z2. So all this means is 5 multiplied by z2, which is 2 plus 3i. which is equal to 10 plus 15i. Okay, and what do I want to do now? I want to add those together because my question was 3iz1 plus 5z2. So when I add these together then, minus 21 plus 10 is going to give me minus 11. And then 12i plus 15i will give me 27i as my final answer. Okay, so a lot of that is just organization, keeping everything, I guess, like keeping everything working nicely as you're going down, just especially if you have time at the end to check back on your work, that you will be able to spot any mistakes. Okay, so what we're going to do, if you're not finished writing any of that down or anything, make a pause in the video. I'm just going to change the numbers and I'm going to ask you to do just a straightforward multiplying again. Okay, because multiplying is going to be the most important skill once we get on to division in the next couple of slides. Okay, so I'm going to get rid of all of this. And all I'm going to ask you to do, I'm going to make up two new complex numbers. So I'm going to say 5 minus 2i and 10 plus I. Okay, what I want you to do, I want you to find z1 multiplied by z2. Okay, so I want you to pause the video while you're doing that, and then when you're finished, click resume, and I'll go through the solution. Okay, so z1 multiplied by z2, that's going to be 5 minus 2i multiplied by 10 plus I. If you want, you can write a 1 in front of that I. Okay, it's kind of like an algebra. If you're just given an x, you can write it as 1x. Okay, so now I'm going to write down the second bracket twice. And then 5 minus 2i. Okay, 5 by 10, 50. 5 by 1i will be 5i. Minus 2i by 10 will be minus 20i. And minus 2i by i will be minus 2i squared. Tidy it up, so 50, 5i minus 20i is minus 15i. If you're not sure of that, just put in 5 minus 20 into your calculator. And then we're going to change I squared to minus 1. So that'll be 50 minus 15i. Now be very careful here. Two minuses being multiplied by each other. A minus multiplied by a minus will give me a plus 2. So my answer then is going to be 52 minus 15i. Okay, that skill is going to be really, really important when we get on to division. Okay, because we're going to see it again there. So just an important one to be able to do before we move on to kind of when it comes up in a harder question. Okay, now, next thing we need to look at is the conjugate. Okay, now the conjugate is a hard word and there is a little bit of, I guess, how will we phrase this? There is a little bit of learning in this. So we're going to have two symbols, the conjugate and the modulus, and you need to know the difference between them. Okay, so just a few notes on the conjugate. The symbol is just Z with a line on top of it. Okay, so anytime you see that symbol, I would actually, on my exam paper, just write the word conjugate just to remind yourself what it means. Okay, and the method, all you do is change sign of I. Okay, so if I was a positive, you'll change to a negative change to a positive. Okay, so this example here, we're given that Z is minus 3 plus 7i, and we're asked to find Z with that weird line on top of it. That weird line on top just means conjugate. How do we find the conjugate? We change the sign in the middle. So that is going to be minus 3 minus 7i. Because this was a plus, we change it to a minus. If it was a minus, we would change it to a plus. Okay, and this last part then again is just kind of keep going with the addition because it comes up quite a bit. So Z is fine. We know z is equal to minus 3 plus 7i. We need to find 2 times the conjugate of z. So that'll be 2 multiplied by minus 3 minus 7i. We found the conjugate of z here. Multiplying the 2, that will equal minus 6 minus 14i. So 2 times z conjugate is minus 6 minus 14i. And we're being asked to add those together. Minus 3 plus minus 6, you can pop it into your calculator, will give you minus 9. And 7i plus minus 14i will give me minus 7i. Okay, so we just keep building with those addition skills. It is fairly straightforward. It is just your regular algebra. It is just a case of, I guess, practicing and practicing until you have that kind of linked to your complex number knowledge. Okay, sometimes people just find the i's a little bit harder to work with than your x's or y's. Okay, that's your conjugate. Next part is probably the most important thing, and it's a place where students score really lowly in this question, and it is division. Okay, so complex number division, there is a few steps that you need to follow. Okay, so how do I know first this is a division question? We've a fraction, we want to divide 11 minus 7i by 2 plus I. Okay, so step 1, we're going to multiply top and bottom by the conjugate of the bottom. So in this case, we're going to multiply by 2. It was plus I, the conjugate will be minus I. Okay, so I'm going to write down my question. And then I like to put in a different colour just to make it nice and clear. We're going to multiply top and bottom by the conjugate of the bottom. Okay, so that 2 minus I is the conjugate of 2 plus I, and that goes on the top and the bottom. Okay, a lot of people tend to put different numbers on the top and bottom. You're not allowed to do that. So you need to multiply top and bottom by the same thing, and it's the conjugate of the bottom. Okay, step 2 then. Now obviously in your exam you don't need to write out these steps, but if it helps you, it's no harm if it keeps your question nice and structured. So step 2 then, we're going to find the top and the bottom. Okay, so we're going to do this separately. So over here I'm going to do 11 minus 7i multiplied by 2 minus I. So I'm just going to work out what the top is. Okay, so write down the second bracket twice. Split up the first bracket. So that'll be 22 minus 11i minus 14i plus 7i squared. That will be 22 minus 25i plus 7 by minus 1. Replacing I squared at minus 1, that golden rule of complex numbers. That will then leave us with 22 minus 25i minus 7, which will be 15 minus 25i. Okay, so that is going to be important. That is our top done. Now we're going to do the same thing with the bottom. So we're going to multiply 2 plus I by 2 minus I. Write down the second bracket twice. Split up the first bracket. Okay, what you should notice here, the minus 2i and the plus 2i will cancel. So it'll be 4 minus, now I squared you change to minus 1, which will be 4 plus 1, which will be 5. Now, a very important, and it'd be good to make a note of this, when you multiply at the bottom, you should just get a normal number, okay? If you don't, so if there's any i's left when you multiply at the bottom, you have made a mistake somewhere along the way, okay? So just make a note that when you multiply at the bottom, you should always be left with just a real number, no i's involved. And last, step 3 then, you're just going to put fraction back together. Okay, so I'm going to put 15 minus 25i on top, divided by 5. Now I can simplify this just that little bit further. I can change that into 15 over 5 minus 25i divided by 5. 15 divided by 5 is 3. 25 divided by 5 will be minus 5, and we still have our I. So our final answer there, 3 minus 5i. Okay. A lot of people, what they tend to do is they don't learn the steps, and then they end up just trying to divide like 11 by 2, and yeah, you will get no marks for that. So your first couple of marks come from picking out that, okay, I need to get the conjugate at the bottom. That will get you your first couple of attempt marks. Then how it usually goes, then you'll move up to the next few attempt marks if you get either of these right. Then if you get this right but don't simplify it, and then this will be for your full marks at the end. Okay, comes up extremely regularly. We'll have the questions I've picked out all include this when we get to the exam questions in a second. Okay, now I'm going to do one more question on division just because it is such an important question. So I'm going to rub out most of this, okay? So I'm going to change the question, but I'm going to leave the steps in there to guide you. Okay, and your new question is 3 minus I divided by 2 minus 2i. Okay, and I want you to follow those steps. I'm going to do it now. Okay, so if you want to give it a go, which I really strongly advise, pause the video and give it your best attempt. If you get stuck, obviously resume the video, try and get the next step, and see how far you can get. So first step, I'm going to rewrite my fraction, but I'm going to multiply top and bottom by the conjugate of the bottom. Conjugate of the bottom, in this case, will be 2 plus 2i. Just change that minus sign to a plus. Okay, and we're going to multiply by 2 plus 2i on top and on bottom. Okay, first probably 3 out of 10 or maybe 5 out of 15 marks got for that. Next step then, we are going to find the top and the bottom. So we're going to multiply out the top and the bottom separately. Write down the second bracket twice and split up the first bracket. Minus I multiplied by 2i will be minus 2i squared. 6i minus 2i will be plus 4i. Minus 2 by minus 1. That will be 6 plus 4i plus 2, because it's the 2 minus sign, so it will be 8 plus 4i for my top. Okay, same thing for the bottom. And in the back of my head, before I even start this, I know I should end up with just a normal number. Okay, just a real number on the bottom. So it'll be 2 minus I. Sorry there, I've just actually noticed a very small mistake. Now it hasn't affected the question yet, but we're just missing our 2 here. Okay, so I'm multiplying top and bottom by 2 plus 2i. So now just when I'm multiplying out the bottom, that will be 2 minus 2i multiplied by 2 plus 2i. Okay, write down the second bracket twice and split up the first bracket. Okay, you can probably see now how important multiplying is, just because it can come up as a multiplication question. It can come up like with multiplication and addition, and of course it can come up in division here as well, which is a really common exam question. Now we're going to keep multiplying this out, so it'll be 4 plus 4i minus 4i minus 4i squared. Cancel out. We're going to replace my I squared at minus 1. So it'll really be 4 plus 4 when those two minuses multiply, which will give me 8. Okay, so that is my top and my bottom multiplied or out. Now I just need to put them back together. So it's going to be 8 plus 4i divided by 8. I can simplify that a little bit. So it's going to be 8 over 8 plus 4i over 8. Okay, 8 over 8, 8 divided by 8 just gives me 1. 4 divided by 8 gives me a half I. Okay, it is not unusual to get kind of fractions or not nice numbers out of these questions. Obviously it's nice when they do divide in nice, so I suppose this one does here, just if the half isn't bad. But if you do get odd numbers, just remember how many attempt marks you could have picked up. I wouldn't spend a lot of time trying to figure out why my numbers aren't too nice. You may actually be correct. But if you have things structured correctly and you've shown all your work, you can still get lots and lots of your attempt marks. Okay, we will see this in an exam question anyway later on. So the last thing we're going to do today, and the last kind of thing that's very specific to complex numbers, is the modulus. Okay, now this actually came up in the 2023 question where they actually wanted your understanding of the modulus, not just being able to form it. Okay, so what the modulus is, it's the distance from complex number to 0, 0. Okay, so I'm going to show you now, we're going to go back to our Argand diagram, or when we were plotting the points, just to see what I mean by that. Okay, so here I'm going to get rid of some of this now. Do that for a second. Okay, so I'm going to draw a straight line, or as straight as I can, connecting that complex number to the origin, or to 0, 0. Okay, the length of that line is the modulus of Z1, or Z2 even there. Okay, I can do the same thing here with this point here, so I can draw a line from here to here, and the length of that line is the modulus of Z2. Okay, so having an understanding about what we're actually doing is important. Okay, so that's what the modulus means. Now, for the modulus as well, you have a formula and you have a symbol. So our symbol it's two lines down the side of the complex number. Okay, don't get it confused with conjugate, people often do. There's actually a formula for this as well that you need to know off by heart, and it's a squared plus b squared. Okay, so need to know the symbol, need to know the meaning, need to know the formula. It sounds like a lot, but it's actually not too bad. So we're going to look at these three questions here. So the first one, we're looking for the modulus of u. Okay, usually we use z, sometimes they throw in other letters, don't be surprised if they do. So the modulus of u, if I was given this question, the first thing I'd write down the formula. Second, I see those symbols, I'm like, okay, modulus, formula. Next thing then, we need to figure out what a and b is. So a is just the number on its own, so a is 5, and b is the number that comes in front of the I, so b is 2. So it's going to be the square root of 5 squared plus 2 squared. Make sure you use a bracket. It's not actually that important here because these are positive numbers, but if they were negative numbers, you need to use your brackets or you will be getting the wrong answer. So I always just say just use the brackets anyway. Okay, to avoid any mistakes. Okay, and I get that the modulus of that is the square root of 29. Not the nicest number in the world. I'm not going to change it unless they say correct to however many decimal places. So that is the distance between, if I plotted that complex number and I measured or I found the distance between that and 0, 0. Okay, next one then, it says the modulus of u plus w. Okay, so what I'm going to do here, first I actually need to find u plus w. And I'm going to find the modulus of that. So u plus w, we're going to add the real parts. So our real parts are 5 and 2. So that would be 7. And then we have 2i plus 4i, that's going to give me 6i. Okay, so I haven't found the modulus there. All I found is u plus w. Okay, now I'm going to find the modulus of that. So I'm going to say that u plus w, the modulus, is equal to 7 squared plus 6 squared. Which is the square root of 85. Okay, so just be careful, add them first and then you find the modulus. What often comes up with this, and I think students find the question a little bit intimidating, something like part 3. So you want to show that something is true. So this question says that show the modulus of u plus the modulus of w is bigger than or greater than the modulus of u plus w. Okay, now I'm just going to write this down and then I'm going to fill in what I already know. So we want to show, and when they say show, we know it's already true, so we know this should work. So I'm just writing down the question again. Okay, modulus of u we actually already know is 29. We haven't found the modulus of w yet, I'll find that in a second. But we know the modulus of u plus w we just found there in part 3 to be 85. Now I just need to find the modulus of w. I'll just do it down here quickly. It only takes 2 seconds. W was 2 plus 4i. So it'll be 2 squared plus 4 squared. Which is equal to 2 squared plus 4 squared, 2 root 5. Okay, so I can fill that in there. Now, is this true? What I'm going to do, I'm going to rely on my calculator. So I'm going to put in square root of 29 plus 2 root 5. I'm going to write my answer as a decimal. So it's otherwise it just comes out in the same form. So I'm going to say that it's 9.8573. Okay, and I'm then going to find the square root of 85, which is, sorry, now that actually shouldn't have an equal to sign, it should have a greater than sign. Okay, now I hope whatever number I'm going to get out for square root of 85 is less than 9.8573, and it is, it's 9.2195. Okay, which is true. What you can write there is going to cut out kind of a short conclusion that will work for everything. Therefore, we have shown that, and then just repeat the question. Modulus of u plus the modulus of w is equal to, or is greater than the modulus of u plus w. Okay, so those questions, those kind of proving questions or showing questions, they're not any more challenging. It's just, I think, the way that things are phrased sometimes causes a bit of confusion. Okay. Now, that is actually all the content knowledge we are going to cover on complex numbers. There are a few little bits that we've missed out on, but it's impossible to get it all done in the time of a video. But we are going to look now at the exam questions that have been fully about what we've just covered there in the last 39 minutes or so. Okay, so on to the exam questions. So this was the 2023 question, and it was question 2 worth 30 marks. Okay, and I'm going to try and convince you in this question that this is probably I think it is the nicest chapter on paper 1. Students don't tend to think so, but hopefully by the end of this you'll see that there's very little they can ask. Okay, so the complex number Z1 is shown on the Argand diagram. So we can see here, I've kind of ignored all of this. They've told us that I squared is equal to -1, might be useful to us later. But part 1, what it actually says is plot and label Z1 conjugate, the complex conjugate of Z1 on the diagram above. Okay, now an awful lot of words there. I'm going to work out here to the side, and I'm going to say that Z1 is equal to 3 minus 3i. Now, they haven't asked me for that, but they've said something about the conjugate of Z1, so I can just make a note here. The conjugate of Z1 is equal to 3 plus 3i. And it said just to plot and label the conjugate of Z1. So I'm just plotting 3 plus 3i. And I'm labeling it as Z1 conjugate. Okay, that's all they were asking there. What tends to happen is this question, the way it was laid out, people might miss this, and then they might actually miss part 2 as well and just go straight to the questions and boxes. Really read your questions carefully. Okay, then they tell us that Z2 and Z3 are 2 other complex numbers. Plot and label them on the diagram above. So they tell us that Z2 is 5 plus I. 5 plus I is here. Okay, make sure you label it as well. You will not get full marks without labeling it. And that Z3 is 6 minus 2i, which is here. Okay, nice question to start. You will see that the majority of complex number questions that have come up before have started with something like that. Then part 3, write 4 times Z2 minus 5 times Z3 in the form A plus BI. Okay, second I see this question, we're going to split it up. So I'm going to do 4 multiplied by Z2, which is 5 plus I. It's going to find out what that is. That's going to be 20 plus 4I. And 5 times Z3, so it's going to be 5 times 6 minus 2I. Which is 30 minus 10I. Now, what the question does here, it wants us to subtract it. So 20 minus 30 is going to give me minus 10. And 4I minus minus 10. So here we have 4I minus minus 10. I should have there as well. That's going to be 4I plus 10I, which is going to give me plus 14I. Okay, when you're minusing a negative number, it changes the signs to positive, so you'll actually end up adding them. Okay, again, a lovely question. Things that if you watch this video, you will have prepared and be able to apply your knowledge directly. Next thing, work out the value of those weird lines in Z3. Straight away, I see those lines and I'm thinking modulus. I have my formula A squared plus B squared. We're looking for the modulus of Z3, so I'm just going to write down Z3 is equal to 6 minus 2I. Okay, so the modulus of Z3 then is square root of 6 to be squared plus minus 2. Okay, few mistakes people will make here. They'll try and put the I in as well, but I can't go into your calculator and then you can't get an answer. Also, forgetting the brackets will also lead you to the wrong answer in this question. And I get out 2 root 10. Now go back out to my question. It said give my answer in third form. All third form means is that there's a square root somewhere in your answer. Okay, I have 2 root 10, which is in third form then. Okay, and the last part, part B then. So this really tests our understanding of, I guess, some of the things that we've applied in this question. So the complex numbers Z4, Z5, Z6 and Z7 are shown in the Argand diagram below. The diagram is to scale. Tick one box to indicate which of Z4, 5, 6 or 7 has the largest modulus. Okay, now we don't know what number, like the coordinates of say Z7 there. Okay, so we can't calculate the modulus. But I'm thinking, what do I know about modulus? It's the distance from the point to 0, 0. Okay, so I'm going to draw a few lines here. So I'm going to draw that line there. Now, obviously, if you were doing this with pen and paper, you'd be able to take out a ruler and would be able to see it a bit clearer. Okay, now what does the modulus mean? It means the distance from the complex number to the center point, to the point 0, 0. Basically, which of those lines is the longest? It is Z5, so that purple one there. Okay, why do we know that that line has the largest modulus? Because it is the furthest away from 0, 0. Could probably phrase that a bit better. That is the greatest distance away from 0, 0. Anything like that will get you your marks there. Okay, so a question really there that kind of tested your understanding, not just if you're able to actually find the modulus. Okay, that was the 2023 question. I personally thought that was a lovely question. Part B, all right, they're a little bit tricky, but other than that, you were really able to show off if you put your practice into adding, subtracting, multiplying your complex numbers, that was really going to pay off for you there. Okay, what we're going to do now, we're going to do the 2020 question, okay, which is also really nice using all the skills we've learned so far. So here, Again, starting off, plotting our points. If you want to pause this and give it a go on all the parts, that would be great, just to see how you get on. So we have Z1, which they tell us is minus 3 plus 4i, and they tell us that Z2 is 4 plus 3i. Plot and label Z1, Z2, and Z1 plus Z2 on the Argand diagram. So first I'll start with Z1 and Z2. So Z1 is minus 3 plus 4i. Making sure to label it as well to get my full marks. And Z2 is 4 plus 3i. Which will be here. Okay, 4 and then plus 3 that way. Now, they also want us to find Z1 plus Z2. So first I'm going to add the real part. So minus 3 plus 4 will be 1. And then add the imaginaries, 1 plus 7i, which will be up here. Okay, a lovely part A, and I'm not entirely sure now off the top of my head how many marks that was worth, but you should be hoping to get your full marks on those part A's. Okay, they're usually quite generous with marks and they're relatively straightforward. Then when we reach part B, this is where people tend to kind of fall apart a little bit with their complex number question, but this is a division question. Okay, division, I've my 3 steps. Now when I'm doing this, I'm going to write it out without the steps, but if you feel more confident writing it out with the steps, of course write down the steps if it helps you to structure your answer. So we want to do Z1 divided by Z2. So it'll be minus 3 plus 4i divided by 4 plus 3i. Now, we know for division, what we need to do is we need to multiply top and bottom by the conjugate of the bottom. So all we're going to do here is we're going to change the sign of the bottom, pop that there, and pop it on top as well. Okay, now I'm going to multiply out the top. So it'll be minus 3 plus 4i multiplied by 4 minus 3i. Write down the second bracket twice and split up the first bracket. Okay, so that'll be minus 12 plus 9i plus 16i minus 12i squared. Okay, that will be minus 12 plus 25i, change I squared to minus 1, minus 12 plus 25i plus 12, they'll actually cancel out, we'll be left with 0 plus 25i. Okay, so all the real parts there cancelled out. It is better in complex numbers just to write in that 0. And now we'll do the bottom. Already I know I'm expecting just a real number. The i's will disappear or cancel each other out in this if I have it set up correctly. Okay, i's will cancel there, so just be left with 16 minus 9, change I squared to minus 1, which will give me 16 plus 9, which will be 25. Okay, put my fraction back together then. I'm going to get the top divided by the bottom. Now, 0 divided by 25 will give me 0, 25 divided by 25 will give me plus 1i as my final answer there. Okay, so those division questions, lovely if you know your method and can do it. Next to impossible to get any marks in it if you have not learned your method. Okay, so you really need to learn, you multiply top and bottom by the conjugate of the bottom. Okay, and then the last part then, find, so the modulus of the conjugate of Z1 minus Z2. Okay, now a tricky question here, I'm going to break this down. So I'm going to first find Z1 conjugate minus Z2. Okay, up here I'm just going to make a quick, well down here I'll do it. Z1 is equal to, Z1 conjugate even. Did we find that already? We didn't. So I'm just going to find Z1 first. So Z1, they told us over here, is minus 3 plus 4i. They told us that in the question. That means that Z1 conjugate is minus 3 minus 4i. And we know that Z2, they tell us that in the question as well, is 4 plus 3i. Okay, we want to subtract them. So it's going to be minus 3 minus 4, it will be minus 7. And minus 4i minus 3i will give me minus 7i. Okay, so z1 conjugate minus z2 is minus 7 minus 7i, and now I can find the conjugate of that. Or not the conjugate, sorry, the modulus. So that'll be the square root of minus 7 squared plus minus 7 squared. It's said to leave my answer in the form of p root q, so something with a square root. So my calculator, if I'm right, should give it out to me in that form, which it does. So it's 7 square root 2. Okay, I would consider that part C there quite tricky because you were asked the modulus and the conjugate in the same question, and they are easy things to confuse. Okay, first two parts there, part A and B, lovely division that you would expect to come up and plotting that you would also expect to come up, and then a tricky part C. But remember, if you'd found the modulus or the conjugate or mentioned any of those kind of right the correct formulas, you will probably be able to pick up some attempt marks on that. Okay, so that was the 2020 question. The last one we're going to look at, we won't have time to go through it, but we will talk our way through it here, is the 2018 question. Okay, so we start off again, plotting, labelling, same thing again, nearly always the start of our question. Next thing, it says investigate if. What do those symbols mean? Those symbols mean the modulus. So the modulus is the square root of a squared plus b squared. So what I would do there, I would find modulus of z3, modulus of z1, modulus of z2, so find them all separately, and then I'm going to set them up. If it's equal to, you can say that that statement is true. So if when you add the modulus of z1 plus the modulus of z2, and if that's the same answer that you got from the modulus of z3, all you need to say is that statement is true. If it doesn't work out, that statement is not true. Okay, that's just your conclusion. No need to overcomplicate the conclusion. Okay, the last part then, question C. I'm just going to get it started. So it's z1 divided by z2. So it is minus 2 plus 3i. Divided by z2, which is minus 3 minus 2i. What do we do for our complex number division? Multiply top and bottom by the conjugate of the bottom. So just change that to a plus 2i. Okay, multiply top and bottom, put your fraction back together. Okay, so very, very similar. Those three questions there that I picked out all really are testing the same content. And there isn't much more. There is a few little bits, but there isn't much more they can kind of add into it. Okay, so we're just coming to the end of the video. What I hope we got from that, we can now plot complex numbers. We can add, subtract, multiply and divide. Put particular emphasis on the dividing because that's that 3 steps. You need to follow those 3 steps. There is no shortcuts. And then finding the conjugate and the modulus as well, which are also extremely common exam questions. And if you don't study them, you won't be able to make an attempt at those questions. You really need to learn your notation and your formulas for those. Okay, so that's the end of this video. I really hope you found it helpful, and I would really encourage people to try their best with complex numbers. It is one